This video is about solving equations containing fractions. There is a four-step procedure to this kind of equations. One, factor all the denominators completely. So the denominators, if they're not completely factored, you factor them completely. Number two, you clear the denominators by multiplying both sides of the equation by the least common denominator. So clear the denominators means get rid of the denominators. How do you do that? You multiply both sides of the equation by the least common denominator. Step 3. Solve the resulting equation. Your equation at this point may be a linear or a quadratic equation that you can solve using the techniques that we have learned so far. And number 4, reject the solutions that cause a zero denominator. When an equation contains fractions and you solve with this procedure, at the end you may find some solutions that are called extraneous solutions because they cause a zero in the denominator, and these are not actually real genuine solutions and you have to reject them. Now let's see how we use this procedure in an example. X over x plus 2 minus x over x minus 2 equals x plus 20 over x squared minus 4. Okay, so first step, factor all the denominators completely. This denominator is completely factored, this is completely factored, but this one is not, and you can factor that. So let me rewrite the equation. And now if I factor x squared minus 4, I get x plus 2 times x minus 2, and as you can see, the least common denominator between this denominator, this one, and this one, least common denominator is actually x plus 2 times x minus 2, because the least common denominator should contain all the factors that are present in all the denominators, and in this case we only have two factors. We have x plus 2 that is present here and here, and we have x minus 2 that is present here and here. So step 2, you have to multiply both sides by the least common denominator. Notice that these braces are absolutely necessary because I want to multiply the whole side, the whole left side, by the least common denominator. Now if I do the multiplications, I get x times x minus 2 minus x times x plus 2 equals x plus 20. So that is because this cancels x plus 2, and when you multiply this by this rational expression, x minus 2 cancels x minus 2. On the other side, the denominator cancels the numerator, and you're left with only x plus 20. So let's simplify that. X squared minus 2x minus x squared minus 2x equals x plus 20. This implies that minus 4x equals x plus 20. This is an ordinary linear equation. Minus 5x equals 20, which means that x is negative 4. So I also completed the step 3. I solved the resulting equation. Now step 4 says you need to check whether the solution causes a zero denominator, and if so, reject it. Minus 4, if I plug in minus 4 into the denominators of the original problem, here I get minus 2, here I get minus 6, and here I get 12. So this solution does not cause a zero denominator, and it is a genuine solution, so I accept. Other problem. One over x minus 4 minus 3 over x plus 4 minus 6 over 5x equals 0. In this equation, I can see x minus 4 in the denominator, x plus 4 in the denominator, and 5x in the denominator. And the least common denominator for these fractions is simply the product of the denominators. So I multiply both sides by the product of the denominators, x minus 4 times x plus 4 times 5x. But I don't need to multiply this other side because I already know the answer. 0 times whatever is 0. So my next step is to distribute this factor and simplify. I get x plus 4 times 5x minus 3 times 5x times x minus 4 minus 6 times x minus 4 times x plus 4 equals 0. Let's simplify that. I get 5x squared plus 20x. This is minus 15. Minus 15 times x is minus 15 x squared. And minus 15 times minus 4 x gives me plus 60x. Okay, and this is x squared minus 16. I get minus 6x squared, and minus 16 times minus 6 is plus 96 equals 0. Next step, I simplify. Minus 5x squared negative 15x squared minus 10x squared minus 16x squared plus 20x and 60x 80x plus 96 equals 0. If I factor out a negative 16, I get x squared minus 5x minus 6 equals 0. Okay, and for this equality to hold, this factor has to be 0. So I only need to solve x squared minus 5x minus 6 equals 0. I can solve by factoring. This is x minus 6 and x plus 1. Equals 0. Because I want the sum to be negative 5, I want the product to be negative 6. That's good. This implies that x is negative 1 and x is 6. So I have two solutions, 1 and 6. Step 4, I need to check whether any of these two solutions cause a zero denominator. Let's check negative 1 first. Negative 1 plugged in here gives me negative 5, here it gives me 3, here it gives me negative 5. So, no problem. 6 plugged in here gives me 2, here gives me 10, here gives me 30. So, none of the two solutions cause a zero denominator, both of them are accepted. Example 3. 1 minus 12 over x squared minus 4 equals 3 over x plus 2. Okay, step 1, I need to factor all the denominators completely. So I have 1 minus 12 over x minus 2 times x plus 2 equals 3 over x plus 2. As you can see, the least common denominator here is x minus 2 times x plus 2, because this is all the factors that I have in the denominators. I multiply both sides by the least common denominator, if I do the multiplication, I get x minus 2 times x plus 2 times 1. That's just x squared minus 4 minus x minus 2 cancels x minus 2, x plus 2 cancels x plus 2 minus 12 equals x plus 2 cancels x plus 2, 3x minus 6. This implies x squared minus 3x minus 10 equals 0. I can also solve this one by factoring. I'm looking for two numbers so that their sum is negative 3, their product is 10. Those two numbers have to be minus 5 and plus 2. Their sum is negative 3, their product is negative 10. That's good. So this implies that x is 5 and x is negative 2. Okay, step 4. Let's check whether these two solutions cause a zero denominator. 5 doesn't cause a zero denominator. It causes 7 here, it causes 21 here. Negative 2 makes this denominator 0. It also makes this other denominator 0, but even if it makes only one of the denominators 0, then it is an extraneous solution. So 5 is accepted, but negative 2 is rejected. We do not accept this. So the only solution is x equals 5. Another example. Three over x plus 3 plus x over x minus 3 equals x squared plus 9 over x squared minus 9. Okay, let's factor both sides completely. This is factored, this is completely factored. This I can replace by x plus 3 times x minus 3, and you see that the common denominator is x plus 3 times x minus 3, and I multiply both sides by the common denominator. Here I get 3 times x minus 3 plus x times x plus 3 equals x squared plus 9. 3x minus 9 plus x squared plus 3x equals x squared plus 9. X squared cancels x squared. This implies that 6x equals 18, which implies that x equals 3. Let's see whether x equals 3 is an accepted solution. X equals 3 causes a zero denominator here. So this is an extraneous solution and we have to reject it. So in this case, no solution. Finally, let's look at a word problem. Double a number minus 10 times its reciprocal is 8/3. Find the number. First step, you need to represent the number with a symbol, and let's use x. Next we have to put it down mathematically. It says double a number, so 2x minus 10 times its reciprocal. Reciprocal of x is 1/x. Reciprocal of y is 1/y. Generally, reciprocal means the inverse. Equals 8/3. So as you can see, I can write this as 2x over 1 minus 10/x equals 8/3. And at this point, it is completely clear that my least common denominator is 3x. I multiply both sides by 3x. I get 3x times 2x minus 10/x equals 8/3 times 3x. This implies 6x squared. X cancels x, minus 30 equals 3 cancels 3 equals 8x, or 6x squared minus 8x minus 30 equals 0. If I factor out a 2, becomes 3x squared minus 4x minus 15 equals 0. Okay, and for this equation to hold, this quadratic trinomial has to be 0. Let's find delta. Delta is negative 4 to the power of 2 b squared minus 4 ac, negative 15. This is 16 plus, if I do this, this is 12 times 15, that gives me 170. So this is 180. Let me use the calculator for this one. (16) plus 12 times 15, 196. 96. So this is 180. Okay, so this is actually a perfect square. This is 14 to the power of 2. So my solutions are x minus b, that is 4, plus minus 14 over 2a that is 6. So it's 18 over 6 or 3, and also negative 10 over 6, which is negative 5 over 3. As you can see, none of these two solutions cause a zero denominator. I only have a denominator x here, and none of these solutions cause a zero denominator. So both of them are accepted. And that's it for solving equations containing fractions.